Now I will discuss the question number 16 to 20 of NEET 2016. When a alpha particle of mass m, question number 16. Of mass m moving with velocity v bombards on a heavy nucleus heavy nucleus of charge Ze. Its distance of closest approach from nucleus depends on mass m as follows. Now the options. First option is m, second is 1 upon m, third is 1 upon root m, and fourth option is 1 upon m square. This is given. So when you read this question, then this will come in your mind that this is the alpha particle scattering experiment done by the Rutherford. So when the alpha particle reaches to the nucleus, then its kinetic energy goes on decreasing and potential energy increases. This is due to the force of repulsion between the two. So at the distance of closest approach, this particle, the kinetic energy of this particle will be converted into the potential energy. That we have to find that if this closest approach, distance closest approach, the mass will depend upon mass, whether this is proportional to mass or 1 upon m or 1 upon m square, like that. This is the nucleus plus Ze. This is the alpha particle. This is moving with velocity v. Then it reaches to this distance and then it comes back. So this distance, this is now this center, and from this center this distance is suppose r0. This is the center and this is the charge plus Ze. So this distance of closest approach is r0. Let r0 equal to distance of closest approach. So this half m v square equal to k z e into 2e upon r naught. Z is the charge of this nucleus, 2e the charge of this alpha particle, and r naught the distance of closest approach, v is the velocity. So now you can see that we have to find this r naught only. R naught equal to 2 k z, 2 and 2 is now 4 k z e square upon m v square. It is asking that when this r naught depends upon mass by which of these options. So you can see that this r naught equal to a constant k dash upon m, where k dash equal to 4 k z e square upon v square. So clearly that this r naught is proportional to 1 upon m. So our right option is second. Answer is second. So this is the answer to this question 16, and you see that the distance of closest approach is inversely proportional to the mass of the alpha particle. Now question number 17. Match the corresponding entries of column 1 with column 2. Column 2. Column 1. This is column 1. This is column 2. Where M is magnification produced by mirror. Where M equal to magnification produced by mirror. This is given. So now options are given here. The column 1, and this is now column 2. Here is A, M equal to -2. And here is convex mirror. And this is B, M equal to -1/2. Here B is given concave mirror. Concave mirror. C, this is given plus with 2, and here this C is given your real image. And D, D is M equal to plus 1 by 2, and here this D is virtual image. And the option is given to be here that this A, B and C, second, no, B equal to B2, B and C, C2, B and D, and this D, that is A and D. No, D is A and D. Here this B2, A2, no, A2, C and D, C and D, and B2, B and D, and C2, B and C, and C2, A and D, E and D. And now second option is A, B, C, B, B is B, C, and C is your B, D, and D is A and D, and now third option, A, C, and B, A, D, and C, A, B, and D, C, D, and now fourth option is A and D, B and C, and C, B and D, and D, this is your B and C. This is now given. Choices are like this. This is the column 1, this is the column 2. You have to match these, that this matches to which one, this matches to which one, this matches to which one. Then you have to find the which will be the correct answer to this question. So it is clear that we are given the value of n equal to greater than 1 and less than 1. Solution. For real image, the m is always negative. For real image. So we are given the convex mirror. M is equal to positive, and this is always less than 1. M is less than 1. For convex, concave, M is equal to, this is always negative because the real image, and M is also to be positive, but here this M is greater than 1. In case of positive, this is greater than 1. And for real image, real image, M equal to always negative, and for imaginary, or you can say virtual image, M equal to positive. So remembering to this one, we have to match these the column 1 with the column 2. So now M equal to minus 2. Minus 2 is greater than 1. Greater than 1, then this convex mirror, this will not match to this one. But concave mirror, this will have the enlarged image. So this is for concave. And negative, so this is now real image. This is now C. So now for A, we are having B and C. For A, B and C. A, B and C. This is now minus 1 by 2, then this is not real. This is correct. But this is less than 1. Less than 1, then definitely this real image, less than real image, in concave this is always greater than 1, and convex this is always for real. And this concave mirror, this M is the image may be equal to the length of the object and less than the length of the object and more than the length of the object. So all three are possible. So this is now also B and C. B and C. And now C, M equal to plus 2. M equal to plus 2. This is now virtual image. M equal to minus 2, M equal to minus 2. Concave, real. This is now right. This will be more than 1. And for plus 2, this is now concave, because when the image is enlarged, then we have the concave mirror. So this C matches to this B. So C to B. And then this M equal to plus 2. This is now virtual image. So this is now D. And now D. This is now plus half. Plus half. So this is for convex mirror. Convex mirror, the image is always small. So this is now A. And this is now virtual image. So this is now I of D. So now you see that which option matches to this one. This is now your B and C. B to B and C. C to B and D. And D to A and D. A and D. So our right option is second. Here the answer is second. So we have to remember all these, and then you have to match the column 1 with the column 2. Then you will get the correct match and the correct answer to this question. And now question number 18. In it, what we have? A particle of mass 10 gram. Moves along a circle. Along a circle of radius 6.4 centimeter. 6.4 centimeter with a constant tangential acceleration. With a constant tangential acceleration. What is the magnitude of this acceleration? What is the magnitude of this acceleration if kinetic energy of the particle becomes equal to 8 into 10 raised to the power minus 4 joule by end of second rotation. By end of second rotation after beginning of the particle. After beginning of the particle. Now your options are given here. 0.2 meter per second square. Second is 0.1 meter per second square. Third is 0.15 meter per second square. And fourth is 0.18 meter per second square. These are the given options. Now this question has been taken from the circular motion. This is now suppose a circle of this is now radius r. The particle is moving like this. Here we have the tangential acceleration. This is now at, and on this side we have this AC, the centripetal acceleration. You are given that this r is equal to 6.4 centimeter. This is given here, radius 6.4 meter, and the mass is given to be 10 gram. So this is your 10 raised to the power minus 2 kilogram, and this is your 6.4 centimeters. So this is 10 raised to the power minus 2 meter. And now you are given that kinetic energy. Kinetic energy. This is your 8 into 10 raised to the power minus 4 joule. And you are also given that second rotation. It means this is the angular displacement. Theta, this is now equal to 4 pi radian. So not so much. Two rotations. In one rotation 2 pi, in second rotation 2 pi. So the total is 4 pi. You have to find the tangential acceleration. This one. This is the centripetal acceleration that we have not to find. So tangential acceleration. AT. This is equal to R into alpha. The centripetal acceleration is equal to V square upon R. So what we have, this R is given to us, but alpha is not given. Alpha is the angular acceleration. So for finding this alpha, we are given these quantities. With the help of this, you can find it. So now you can see that first you are given the mass of this particle, then the kinetic energy. So just you calculate the velocity. Kinetic energy equal to 8 into 10 raised to the power minus 4. This is now half mv square. 8 into 10 raised to the power minus 4. So this is now 1 by 2. M is given to be now your 10 grams. So this is 10 raised to the power minus 2. V square 8 into 10 raised to the power minus 4. So this will cancel by 2. This one by 2. And this is now 16. So B is equal to now 4 into 10 raised to the power minus 1 meter per second. This is the speed of the particle. And then the angular velocity. Omega equal to V upon R. This is now 4 into 10 raised to the power minus 1. This is given to R 6.4 into 10 raised to the power minus 2. So this you can have to be 4. This is now you have 1.6. So this omega equal to 10 upon 1.16. So this is your 100 upon 16. So 4 to 4, 4 to 25. So this is now 25 upon 4. So much radian per second. This is what the angular velocity. Ten, 25. This is not so much. And now you have to find the angular acceleration. So equation of motion, omega square equal to omega naught square plus 2 alpha theta. So here this theta is given to us so much, and this omega naught is equal to 0 because particle is moving from rest. So omega equal to 0, omega naught. So this omega square is equal to 0 plus 2 alpha theta. So now you find that this alpha equal to omega square upon 2 theta. Omega is 25 upon 4. So this is now 25 square upon 4 square into 2 into theta is equal to 4 pi. This is not so much. And if you calculate to this one, then you will remain to be as such. And now therefore AT equal to R into alpha. R is given to be 6.4. This is now 6.4, 10 raised to the power minus 2. Alpha is given to be so much, 25 into 25 upon 4 into 4 into 2 into 4 pi. So much. 4 4 16, 16 to 32, 32, so this is now 0.2. And now this 0.2 is just you calculate, then this will point from remove to this one, this is now 0. So this will be your 2, this will cancel by this 2. Then this is your 10 raised to the power minus 2. 25 into 25 upon 10. This is 10 minus 2. So this is now 2 zeros more. Then this is now your 2 pi is equal to 3.14. So 25, this is now your 4. And now just you calculate, then this will come out to be 0.1 meter per second square. Just you divide this one by this, then you will get this 0.1 meter per second square. So the answer is our choice that we have selected here is 0.1. This is now third answer. 0.1 second. This is now second. This is the one way to find this tangential acceleration. But there is one more method to calculate the tangential acceleration. So I am telling you that it's alternative method for finding the tangential acceleration. Alternative method. In alternative method is what? That you are given the kinetic energy, and this kinetic energy equal to work done. So we apply the theorem of work and energy. Theorem of work and energy. What? This W equal to half mv square. So what we have, this W equal to F into S. This is equal to half mv square. So this F equal to m/a/t. S is this S is the what? The displacement. So this will be equal to R into theta. R into theta. This is equal to half mv square, where F equal to m into at. M the mass, it is a tangential acceleration, and this S, this is now arc. Arc equal to R into theta. Radius into the angular displacement. So now you m and m will cancel. So this at is equal to v square upon 2 r into theta. Now you put. Now you do not cancel to this one because half m v square is given to this 8. This is now 8 into 10 raised to the power minus 4. So much. So this is 8 into 10 raised to the power minus 4. Then this r, this is now your m, and mass is given to be 10 gram. So this is m r into theta. So just you calculate 80 equal to 8 into 10 raised to the power minus 4. M is equal to 10 raised to the power minus 2 into that r into theta. R is given to be now 6.4 into 10 raised to the power minus 2. Theta is equal to 4 pi. Right? So just you have this minus 4, this will cancel. 4, this is now your 2, this is now your 3.2. So now we are left with 1 upon 3.2, then value of pi 3.14. So if you divide, this will come out to be 0.1 meter per second. This is one more method to calculate the tangential acceleration. So this is now short one. So either you calculate like this or you calculate like this, you will get the same answer. But here you have to remember that the force is equal to mass into the tangential acceleration. Because this tangential acceleration is due to the change in magnitude of the velocity. So that will give you the kinetic energy. So the work done will be done by this force, that is the tangential force, while the work done by the centripetal force is always 0. So there is no kinetic energy because of this centripetal force. So you take this, that this W equal to half mv square, and then remember this S. S is the displacement, linear displacement. Arc upon radius equal to the angle. So from that, arc equal to r into theta. So just you have this, and then you can find the value of 80. That will come out to be this one. So again now we have the option second. So this is now question number 18. And now question number 19. So now question number 19. A small signal voltage voltage Vt equal to V0 sin omega t. V0 sin omega t is applied across, is applied across an ideal capacitor and ideal capacitor C. Now option is current IT leads voltage VT voltage VT by 180 degree. Second, current IT lags behind voltage VT by 90 degree. And now third option, over a crystal, over a cycle, the capacitor C does not consume any energy from the voltage source. And now option 4, current IT is in phase with voltage VT. This is the given options. Now we know that in case of the capacitor, current always leads the voltage by 90 degree. The first option, current leads the voltage. This is right work. This is given now 180 degree. This is wrong. This must be 90. So this option first is wrong. Current IT lags behind the voltage by 90 degree. This is also wrong. Over a cycle, the capacitor C does not consume any energy from the voltage source. This is the correct one, because we have seen that in one cycle, first the current is taken from the energy is taken from the source, and then this is returned to the source. So no energy is taken in one cycle of this voltage source. Current IT is in phase. This is wrong. That in case of capacitor, current is not in phase with the applied voltage. So only the correct option is to third one. Solution. The capacitor never consume energy from voltage source. So one right option is what? Third. So this is the direct theoretical question of this capacitor that you would have studied in classroom also. Now you can have the last question, 20th question. 20th question. A disk and a sphere of same radius. A disk and sphere of same radius but different mass. Different mass. Roll off on two inclined planes. On two inclined planes of same altitude and length. Which of the two objects? Now question is, which of two objects get to the bottom of plane first of the plane first. Now this option is depends on their masses. Depends upon their masses. Second, disk and third is sphere. And fourth is both reach at the same time. Both reach at same time. Now question is that if the disk and the sphere of same radius and different masses are allowed to roll on the two inclined planes which have the same altitude and same length, then which of them will reach the ground first? So now here this is like this. This is angle theta. This is now ground floor. This is inclined plane, and this is now your sphere or the that rolls like this. This is given the length, this angle the theta. So time to reach at ground, t equal to, this is equal to square root 2l into 1 plus k square upon r square and upon your g sin z. This is now square root of so much. Now you are given the L is to be constant, sin theta is also constant. So what we have left? T is proportional to square root of 1 plus k square upon r square. So the body for which k square upon r square is small, t will be small. So that will reach first at the ground. It means that if we take disk, for disk k square upon r square equal to 1 by 2, so this is your 0.5, and for sphere k square upon r square equal to 2 by 5, so this is your 0.4. Clearly the value of k square upon r square is less for sphere in comparison to disk. It means that the sphere will reach first on the ground. K square upon r square is less for sphere than disk. So sphere will reach ground फर्स्ट. सबसे पहले स्फीयर पहुंचेगा. इसका मतलब ये है कि इसमें जो स्फीयर दे रखा है यहाँ ऑप्शन के अंदर स्फीयर थर्ड, दिस इज अवर करेक्ट चॉइस. This is not sphere. So in this way, this is the direct application of the inclined plane on which the body rolls. And just you remember that what is the time taken by the body to reach at the ground, and then you find the value of k square upon r square. So the bodies for which k square upon r square is least will reach the ground first, and for k square upon r square maximum will reach to the ground later or at the last moment. So this is now question number 20. So these are the question 16 to 20 of NEET 2016. Thank you.